Hello everyone, and welcome back to the garage. In this video, we're not going to be doing anything. So, thanks for watching, and I will see you in my next video. In this video, we're going to be doing part 2 of the Gottlieb Haunted House Pinball Machine Restoration Series. We're going to fix the rest of this thing's main problems, and then I'll go ahead and take a look inside the back box, take a look at the boards, and then we'll assess each of the playfields and see what else needs to be done to get everything on this machine all fixed up. So let's get started. So now that we've got the flippers and the trap door working and the upper drop targets mostly working, now I want to solve the issue with the knocker coil because it doesn't fire and I have never seen it fire, and it doesn't fire when you go through the solenoid test. And you might notice this time that the back glass on this machine looks a little bit different than last time. Well, that's because I took out all of the LEDs that were back there and replaced them with incandescent bulbs because I just wanted to see how it looked from the factory, and I think it looks pretty good with warm white. And one thing I also noticed is when you put incandescent bulbs behind the lightning bolts on the back glass, the lightning effect looks so much more real. The LEDs just kind of overpowered it, and it was lighting the area around the lightning bolts a lot more. And the fade out from the incandescent bulbs looks really nice. So in this instance, I'm going to leave incandescent bulbs behind these lightning strikes because I think that looks a lot better. And I was looking through the manual, and it turns out that this game had 3 455 flashers installed from the factory. One right here where this other lightning bolt is, one here behind this window, and one there to flash the crow's eye. So I'm going to leave those there, and I think for the rest of the game, I am going to put all warm white LEDs behind here. I might do red here and maybe blue in these two spots, but for the most part, it's going to be warm white because I think it looks pretty good. But what I wanted to show you is this machine actually had a problem fix itself. In the first video, I said that when I first ran through the solenoid test, it fired about 3 solenoids and then it just blew out the solenoid fuse, and then replacing that brought everything back to life. Well, now if you go through the solenoid test, it works just fine except for the knocker coil. So I'm going to go to hardware. This machine has a knee woomph board installed in it currently, so the setup here is a little bit different. But if we go to coils, and if I hit the start button, it actually goes through and fires all the solenoids. And so it fired every solenoid except for the knocker coil. And so I'm not sure why it blew the fuse the first time. Maybe when that coil tried to fire the first time, it made the diode go open, and so now it's not working. I'm not sure, but I know for a fact we have a problem with that coil. So I'm going to desolder that, and then we can take a look at it. But I want to show you something that I discovered when opening up the back box with the game running. So this game right now has a knee woomph CPU and driver board installed. And if we take a look at the driver board, you can see next to these transistors here that the LEDs next to them are lit. And if we look down here, it says LEDs remain unlit unless activated. Open circuit will light LED continuously. So this board is thinking that those 4 transistors have an open circuit. And I see there's a LED lit here too. I'm not sure what that goes to since there's no transistor by it. But I think that might be a red herring because Haunted House is a System 80 machine, and I think this board can work in System 80, 80A, and 80B machines. And so the LEDs being lit may just be because Haunted House doesn't have as many solenoids, and so the board just thinks that there's nothing connected to them. So that might be an issue, that might not be an issue, because when I go through the solenoid test, everything on the playfield fires correctly except for the knocker coil. So I'm going to go down there now, and we will address that. So here's what's going on with the knocker coil, in case you didn't see it in part 1. The paper surround is missing, and the windings toward the middle of the coil look a little bit darker than they should. So I think this coil has a problem. So I'm going to desolder it from circuit, and I'm going to remove the diode that goes across it. And I'm going to check both the coil and the diode for shorts. And if any one of those is shorted, I am going to replace them with either a new coil or a new diode, and we'll see if it fixes the problem, because I don't think that the NeWumph board is having any issues because it's a new board. The transistors aren't nearly as likely to have failed. So I'm going to check this first. I'll take it out and desolder it, and we'll see what it tests like. All right, I've desoldered the coil and I've removed the diode from the coil so we can individually test each one. And I'll give you a closer look at the windings of this coil. You can see in the center it looks a little bit darker than the rest of the windings. And I think the windings in general should be a pretty bright red, so I wouldn't be surprised if this coil is shorted. The coil sleeve is still good because you can see the knocker itself travels freely through it still, so I can reuse that. But I have a ohm meter here, and we can check to see if the coil is shorted and if the diode is shorted. So I'm going to first check the coil, and it should be around 11 ohms if it's good, but if it goes to 0, if it deflects all the way to the end, then we'll know it's shorted. So let's see what this tests like. Yeah, that doesn't look good. It's not a dead short, but it's reading around 3 ohms. It should be reading around 11. So I think this coil is no longer good. Now let's check the diodes. So there should be no resistance one way, and there should be resistance another way. So let's see what that looks like. Okay, so we have no resistance in that direction. And let's test the other direction. We'll flip the diode around, and we'll test it again. And we do have resistance. So this diode appears to be good. I'll go ahead and test it on a digital meter with an actual diode check just to make sure, but it looks like the diode is fine. All right, let's test these again with the digital meter since it's going to be a lot more accurate. And we'll see what the coil tests like first. Yeah, that's no good. It should be around 11 ohms. So the coil is not good. And measuring the diode, 0.59 seems a little bit low. I think it should be more around 0.7. And so I think what I'm going to do to be on the safe side is just replace both the coil and the diode because I have both. But obviously this is our main problem right here. The coil is reading about half of the resistance of what it should be. So I'm going to replace it with a new one, and I was able to find 3 new old stock Gottlieb coils. This is the same coil as this one here. It is a A5195. So I'm going to get one of those out, and we'll test the resistance on that. And what's nice about these coils that I have, they've already got diodes on them, so I don't have to solder a new diode back on. And I looked at the diode on here, and it is a 1N4004. The one that I pulled off the original coil was a 1N4001. And the difference between the two is that the 4001 can handle up to 50 volts going in the opposite direction because with diodes, current can only flow one direction. And so it's got protection for up to 50 volts going in the opposite direction, but a 4004 has protection for up to 400 volts going in the opposite direction. So it's a much beefier diode, and you can replace a 4001 with a 4004 just fine. It'll just give you more protection in case you have weird problems like voltage spikes or something. That's what we should see, 11.3 ohms. So this coil is completely fine. I'm going to go ahead and take the old coil assembly apart, take the brackets off, remove the coil sleeve, and then put this coil in that assembly. Well, that's what it looks like now. This is what it should look like. And I went ahead and put a new coil sleeve on it because the old one had basically melted itself to that burned up coil, and had to resort to using a hammer to try to get it out, and even that wouldn't get it out. So I put in a nice brand new coil sleeve into this one, and the knocker moves freely, and everything should be good now. So I'll go ahead and put this back in and we'll see how it goes. All right, the new coil has been soldered in. I'm going to go ahead and start the solenoid test and we'll see if it fires. It does not. Okay, so obviously we don't have just a coil problem. We have a problem with either some sort of wiring or the NeWumpf driver board had a transistor blowout when that fuse blew the first time. So we have a little bit more we need to do to get this knocker coil working. Okay, what I'm going to do first is I'm going to start the solenoid test again. And I want to see what kind of power we have going through that coil when it tries to energize. So if there is power going through it, we should see that on the meter just for a split second. So I'm going to start it. Nothing. Okay. So we do not have any power getting to that coil at all, and there's no difference when the game is off versus when the game is on. So the problem is before the coil. So it must be something to do with the driver board. But before we take a look at the driver board, I just received a few things that are going to make this haunted house look a whole lot better by the time I'm done restoring it. So I've been thinking about the playfields in this machine and looking around them and looking at all the wear, like around the bumpers, around the clear plastic window. It's not flat anymore. The paint swirls and the wear spots on the lower playfield. I decided that since this is a popular and well-known game, and this is one of my favorite Gottlieb System 80 games, I figured I want to do something a little bit special for this game. I went ahead and I bought brand new playfields for the haunted house. And these come from Mirko Playfields, and I think they're based in Germany. And so I just got those today, and I'm ready to unpack them and see how they look. So let's go ahead and do that. That thing is shiny. They're kind of in the way of the camera. It's got a way better, yeah, that's the basement. It's got a way better coating than the original one. This is the upstairs. Yeah, it looks a lot better too, because on the old one it's got a big mylar peeling problem right around here, and so this actually looks good. Thing's gonna look amazing when it's done. Well, there's the basement playfield, and as you can see, it is very shiny, and that's because these modern playfields have an automotive clear coat applied to them, and so they're much more shiny than the original playfields, which the main playfield doesn't have any sort of protecting over it. It's only the upstairs playfield that's got a little bit of mylar over it, so this is only protected by whatever coating Gottlieb used to protect the paint, but on these, it is a much better coating, and so these will have really good wearing properties. They probably won't wear for a very long time. And so that's what this looks like. All nice and perfect. So there's the basement. Here's the upstairs playfield. Also the same type of clear coat over that. Let's see how nice that looks. And the main star of the show here is the main playfield. And as you can see, these are made by Mirko Playfields in Germany, and they were reproduced initially starting in 2018. So there's the main playfield. And so this is what the haunted house is going to look like after I am totally done restoring it. It's going to look really good. What I am going to do for this playfield is put in a brand new plastic window for this part because the old one's pretty scratched. and it doesn't make sense to put an old scratched plastic into a brand new playfield. So I'm going to replace that with a new one, and I'm also going to replace the spiderweb cover on the basement playfield with a new one because it's pretty scratched as well. And when the game's running and the basement playfield lights are on, you can definitely tell the difference when you look through the spiderweb cover versus the part where there isn't a cover. And same goes for the main plastic. You can definitely see the scratches when the basement lights are on. So those are going to get replaced. And as far as the rest of the plastics go for this game, I was able to find a complete set, brand new, of Haunted House plastics for all of the playfields from Steve at Pinball Resource. They go and they make brand new plastics for this game, and so I've received those as well. And so not only will we have brand new playfields, we're also going to have brand new plastics, and it's going to look like it just came out of the factory. So I am very much looking forward to how this game turns out when I'm done. It's going to need a lot more work than just that because a lot of the metal parts in this game are starting to oxidize and rust, like this frame here around the upper playfield. You can see that there's rust starting and it's gone all over the frame. And there's a lot more metal pieces both on the playfield and under the playfield that have the same thing happening. Like the screws right there, those don't look good at all. So I'm going to be making those look better. So I got a lot of work ahead of me. I've never done a playfield replacement on a pinball machine, but I know what it takes, and it's not an easy job, especially for a machine that has 3 playfields. So I'm going to have my work cut out for me. We're not going to go there just yet. We still have some problems with this game we need to fix. But when we eventually do the playfield restoration on this game, it's going to be a lot more involved because instead of trying to clean up and restore the original playfields as good as possible, I'm just going to straight up work with the new playfields. So what this will end up being is taking everything off of all the playfields, every piece, every screw, every mechanism, every wire, to the point where the old playfields are just bare wood, like these new ones here. And I'm going to have to swap every piece over to the new playfields. And so we're going to do each playfield one at a time. I'm probably going to start with the upstairs playfield because it's the smallest, and you can remove that playfield too from the main. It's pretty easy to remove. So that's probably the one I'll go with first, and then I'll do the basement and just get some practice in with the smaller playfields. And then the last one we'll do is the main playfield to tie it all together. So I'm excited for how this machine is going to look after all that is said and done. But let me go ahead and show you those new plastics that I got as well. And so these are the brand new plastics I got from Pinball Resource. And these are not just new old stock plastics. These are actually brand new. They were made in recent years by Pinball Resource themselves. And I haven't even unpacked these yet. I've just kind of had them sitting around for a while. And each one of them has a little protective film over the top, so that's why they look kind of funny. So that's one of them. So every plastic in this game is going to get replaced with a nice, shiny, brand new one. I'm going to go ahead and just leave those in there, and we'll get to those when we actually start restoring the playfield. So we have those as well. And so it's going to look really nice when we're done. So now let's take a look at the driver board and see if we can fix the problem with the new knocker coil not working. And I've been taking a look at this board, and I have found something that I think is a pretty big tell as to what might be going on. So what I'm going to do is I'm going to start up this machine's solenoid test again. And what you're going to see is these 4 transistors at different points. Each one of them will have its corresponding LED flash for a second when its solenoid fires. And this transistor here, I believe, is for the knocker coil. And I want you to watch the LED on this one and see what it does. So I'm going to go ahead and start that. Okay, I don't know if you could see that because it was pretty dim, but when the knocker coil tried to fire, this LED actually did come on, but it was very dim. And so what that's leading me to believe is we have some sort of transistor failure, either with this transistor here or something directly around it. So what I'm going to do is pull out this board, and we're going to test the transistor and the things around it and see if we can find a fault, because I think that's where the problem is. And another board-related problem we need to fix is the little lightning effect board in the back box. So you can see what it's doing. It's flashing these lights up here in the top, and it does it 3 at a time. So for every transistor on that little board, it flashes 3 lights at once. But you can see that we have 2 sections, these 3 lights and these 3 lights, that aren't working. And I put known good light bulbs in there, so we have a problem on that little lightning effect board. And so this board has several different driver transistors on it for those lights. But if you look up here, one of those transistors is missing. So that's at least one of the problems. I don't know if there's another one that's bad because we have 2 sections that aren't working, but obviously I need to pull this board out and replace this missing transistor and test all the rest of these to see if they're working properly. So I'm going to go ahead and pull that board as well as the driver board, and we will do some electrical testing. All right, first let's check the transistors on this auxiliary lamp driver board and see if any are bad. And I think I know which one it is. There's a little bit of a burn mark on this one right here. So I think this transistor might be shorted. I'm going to test them all and we'll see what we got. Okay, so I'm testing this part and it's reading 0.6 voltage drop. That's normal. And then the other part is reading 0.7. That's good. So this transistor's fine, and we're just going to look for that on all of them. So that one's good. That one's good. This is the one that I think has a problem. That side's good. What about this side? It's open. So I was right. These 2 leads here no longer have a connection, so that transistor's open. So I'll have to replace that one. So 2 bad transistors, well, 1 bad one, 1 missing. That one's good. That one is good. That one is good. This one is good, and the last one is good. So there are problems right there. Need to replace this transistor and replace this missing one. And the transistors that are used on this board are MPS U45s, and I have some brand new ones right here. So I'll be replacing the bad one and the missing one, and then that should bring this board right back up to life. All right, I found the real problem. It had nothing to do with the new driver board. See that little piece right there? What do you think that means? I went and looked at the connector that went to those transistors on the driver board, and I looked inside, and one of the pins had a broken connection. And I traced that pin out to the same contact on the connector on this board, and it goes right to the transistor for the knocker. So that's your problem right there. I need to repin that connector so that it works again, and then the knocker should work. So for now, I just reinstalled the driver board and the auxiliary lamp board, and you can see that all the sections here are now pulsing like they're supposed to, but over here, the section that wasn't working before is now staying lit. And as you can see, it's kind of flickering between fully lit and a little bit dimmer. So maybe that transistor I put in for that specific section was bad, and it's not allowing the lights to turn off. I'm not sure, so I'll have to inspect that. All right, after taking a look a little more at this auxiliary lamp board, I have figured out why that one of those sections stays lit all the time. So right now, I have this board powered from my bench power supply. It only takes 5 volts, so it's easy to power up out of the game. And so the board right now is doing exactly what it does when it's installed in the game. And so I have my oscilloscope set to a really slow scanning mode. So what I'm going to do is hook up the scope to one of the output pins on this connector here, and you'll be able to see the pulses on the scope. So I'm going to hook the probe up to this top pin right here, which is connected to one of the transistors that I just replaced. And so when I do that, you're going to see little pulses on the scope. See those little pulses occurring periodically? That's the board pulsing that line to turn on the lights really quick. And so that's what that looks like electrically. But the section that was staying on all the time was the one that I replaced the other transistor on. So I'm going to hook up to that pin and look at the difference. See how the signal is high all the time? That means the lights are on all the time. And that shouldn't be happening. It should be pulsing like it was doing on that other one. So I took a look at the schematic for this board, and it's fairly simple for how it operates. And I went ahead and tested that transistor off camera, and it tests perfectly fine. So we know the problem is not the transistor, it's occurring before the transistor, because the only thing after the transistor is the output connection. And so the first thing that's before the transistor is a 12K ohm pull-up resistor, and that pulls the signal up to 5 volts. And I tested that resistor, and it measured spot on 12K. So the resistor is not the problem. The next thing after the transistor is one of the two 7405 ICs on the board. And how a 7405 is supposed to work is it takes an input and inverts it. So when we hook up to an output pin that's working, I'll hook up to the one that I showed you before with the pulsing. So that signal, when you hook up to an input pin on a 7405, it's going to be the opposite of that. There will be a high signal and then a short pulse down to ground and then back up. So it's going to be the opposite of that. And so on this board, there are two of those 7405 chips. One controls the first 5 transistors and the other controls the other 5. And it's this one here that is in line with the transistor that's not working. So we know this chip is working at least somewhat because 4 of the transistors are working, but we need to measure the input and the output going specifically to this transistor here. And so the output that goes specifically to this transistor here that I replaced is pin number 10 on this IC right here. So if I probe pin 10, which is the output going right to that transistor, you can see on the scope that it is stuck high. So we're getting the same signal that we did when we probed the output pin on the connector. And now we need to probe the input that corresponds with that output to see if the problem is with the chip or before the chip. And so that input is pin 11. So if I probe pin 11, look at what we see. 2 pulses going from high down to ground like I said it would. So the input is working fine, but if we probe the output, you can see it's just stuck. So that tells you right there that this IC is bad, and that is the reason why the lights are staying on all the time, because the output is stuck high. So I need to replace that 7405 chip to get this board fully working. Luckily, I have a whole bunch of parts Gottlieb System 1 CPU boards that have battery corrosion and bad spider chips, and they have a couple 7405 chips on them, so I can steal one of those and put it on this board, and I'll test it before doing that, and that should bring this board back up to life. Well, I removed the chip, and you can see on the board there is a little burn mark that is under the trace that goes right to that bad output. And my soldering iron did not make that mark. So what I think happened is the chip failed and it caused the transistor to fail. So we solved 2 problems with this board: chip fail and transistor failures. And so to test out the new 7405 that I pulled out of one of those parts System 1 boards, we're going to be using this. This is called the Retro Chip Tester Pro, and you can either buy it in kit form or fully assembled. Of course, I bought the kit for him because what's the fun of buying one if you don't get to put it together? And what this does is it mainly tests old memory chips, but it also tests ROMs, EPROMs, and logic ICs. And so if we go ahead and plug it in, it comes up, the display shows you what it's doing. And so we're going to use these buttons to navigate to the logic IC section. So right now it's on SRAMs. And you can test DRAMs, EPROMs, PROM and ROMs. Here's logic. So we hit OK. And the 7405 is going to be under 7400 plus logic tests. Hit OK, and then we go to 7405. So there's the 7405. And then what we do is take the chip and put it inside the ZIF socket and close the lever. And we hit OK to test it. And the chip is OK. And so that's a very quick way to test older chips like this. And so if you want to test static RAM, dynamic RAM, ROMs, and logic ICs, this is a really good tool because it makes it so you don't have to power the chip up and test it with an oscilloscope. And you can hit OK if you want to test it again just to make sure. And it says it's OK. So this chip is good. I'm going to go ahead and put that in the lightning effect board. And then we'll go put it back in the machine and see if everything works. And so that's what that board looks like with the new 7405 here and 2 replacement transistors. And with the game running, it's totally working now. All the sections are now pulsing exactly like they should. So that little board had quite a few problems. A missing transistor, a bad transistor, and a bad 7405 chip. But now it's working perfectly, and so the lightning effect can be enjoyed in all its glory now. And since I don't have any of those crimp terminals left and I'm waiting on some to arrive, I think we'll go ahead now and try to repair the original Gottlieb CPU board. And I've taken a look through this thing, and I don't think it's going to be that complicated of a repair because most of the traces seem perfectly fine, and the only problems I've seen with this board are just some missing components. I went ahead and I tested the U2 and U3 ROM chips as well as the Haunted House game PROM, and they all read out perfectly, and I backed up their contents. So those chips are working. And whoever worked on this board last must have replaced a lot of chips because you can see there are a lot of them that are in sockets. And these chips were never in sockets to begin with. You can see there's a whole bunch that are in sockets. I tested those in my Retro Chip Tester Pro, and they all test good. So we've got good, promising results so far. And the only problems that I've seen on this board are around this little area right here. So the first thing is we've had a via and a trace start to peel away from the board right here. And so whoever had this board last soldered in a little jumper wire through that via to the intact trace on the other side right there. So that trace has been repaired. And that's the only bad trace I've seen throughout this whole thing. All the rest of them look perfect. So that's another plus. But up here in this section, we have a whole bunch of missing and incorrect components. There's a whole bunch of capacitors and resistors and diodes that are supposed to go across these points here. And there are supposed to be 2 transistors in those spots. You can see we have Q2 and Q4. This transistor is in the incorrect spot, and it's not the right transistor. There's supposed to be a transistor here, and there's supposed to be more resistors, capacitors, diodes across these points. And same goes for up here. There's some missing resistors and capacitors kind of up all through around here. There's supposed to be a chip right here, and there's a couple wire jumpers in there for some reason. So I bought the correct chip, and I'm going to install a socket so that I don't have to desolder the chip if it goes bad. I'll do the same thing like was done with this chip and put that chip in the correct spot. And looking through the parts list on this board, this chip in this socket is incorrect. So I'm going to swap that out with the right chip. But Those are all the problems I've seen with the board. Incorrect chip and a whole bunch of missing components over here. So I'm going to go ahead and clear out all of the wire jumpers, all of the incorrect components, and clear out the solder that's in these holes so I can repopulate them with the correct components. I'll replace that chip, and then this board should be fine, and we should be able to put it in the machine and test it. All right, I am starting to make my way through this board. I went ahead and cleared out all of the holes that I need to put components in, and the pads look kind of questionable, but I do think that there's still metal on all of them, and all I need to do is just a real light sand with a piece of sandpaper, and those pads will look a whole lot better. So I cleared all those out, and I cleared out the spot here and installed a socket and a chip. So I removed those little wire jumpers that were in there for some reason, and so now the correct chip is in place. And I swapped out this chip with the right one, so all I have to do now is just repopulate all of the missing passive components where the holes have been cleared. All right, I have finished installing all of the missing components on this board. So this little section here, all the caps, diodes, resistors have now been soldered in. All the correct values have been put where they're supposed to be. I replaced these 4 missing transistors, and of course I soldered in this chip. So everything there is now back how it should be. And I also went ahead and made a change to these replacement ROMs. These chips are in sockets, and these are connected to little adapter boards so that they can interface with the CPU board. The adapters were also in sockets, and so I decided to just remove the sockets and solder these adapter boards in directly, because this one had a hard time fitting into the socket, and I didn't want to have the machine lock up if that ROM adapter wasn't making a good connection. So these adapter boards are now soldered directly into the board, and these chips are still in sockets, so I can remove them if I need to. And it's not like I'm going to try to find original ROM chips to put back in here. I'm just going to use these because these are more standard chips. So I think that looks better. It doesn't jut out as far, so that looks better, I think. So now we're ready to put this board in the machine and see if it'll start up on its original CPU board. And that is what that looks like all connected up in there, the original System 80 CPU board. And I did end up finding out what this little board up here was for. It turns out this is an original Gottlieb board because it has a Gottlieb part number in the back. And I looked up that part number, and this is a reset board for a System 80A or 80B machine. So while it's an original Gottlieb board, it is not supposed to be in this machine because those weren't used until System 80A, which came out only a couple games after Haunted House. And the back boxes of System 80 games that I've seen, this board is held in with clips, just like how the original boards in this machine are. And this one's held in with screws, and it's got metal threads behind the backboard. So either someone did a really good job adding this board in, or maybe it's a really late Haunted House and they started adding them in. I have no idea. And there's supposed to be a little wire connector that goes from here into this plug here on a System 80A or 80B machine. But now I know that board isn't necessary. Maybe if I get another System 80A machine in the future that needs that board, then it'll be there for when I need it. But let's go ahead and power up this machine with the board and see if it works. So this board is going to operate a little bit differently on power up than the NeWIMF board. Instead of powering up and going to attract mode immediately, what it should do, if it works, is as soon as I power on the machine, the general illumination should come on, and that's basically all it will do. And then there will be a 5-second delay, and then after that delay, it'll click the mechanical relays in the machine a couple times, and then it'll go into attract mode where the displays will come on and the lights in the playfield will start doing their thing. So let's turn it on and see what happens. Okay, I heard coils. Okay, all the lights are on. And I saw displays when I turned the machine off. Let's try it again. Okay, it just did the same thing. Huh. Well, it isn't working, but it turned on all the CPU-controlled lights. So I mean, that's something. Well, I took out that board and I put some contact cleaner on a magic eraser and scrubbed the edge connectors, and that's how much dirt came off of them. So that might do it. Those connectors were super filthy, and looking at the board, they actually look really good. You can see there's no damage whatsoever, and if I turn it over to the back, look at how nice they look. And this is kind of one of the reasons I wanted to try to repair this board, because there's like no battery damage whatsoever. It's in really good shape. So I'm going to put this back in and we'll see if it works. I have my doubts, but with that amount of dirt, that might just change something. Well, it blew out the solenoid fuse, so that's why we heard the coils go on and then right back off. It must have locked all of them on and then blew out the fuse. Just like it was doing with the lights, it had all of them on. So the board must be telling the driver board to turn everything on all at once. So obviously it has a problem, but I'm going to try something different this time. I read online that if you don't use this little reset board up here, some of these CPU boards will just refuse to do anything and not work properly. And so the fix is to add a 3K ohm resistor across pins 7 and 11 of that connector right there. And so I just kind of tacked one in just to test this out. So I'm going to power it up again and we'll see if anything changes. And I'm going to leave the solenoid fuse out because I don't want to blow another one again. So we're not going to get any coil activity, but after about 5 seconds, we should get displays if everything works. And it is still telling all of the lights to turn on. So obviously there's a problem still. And I've noticed that sometimes it won't tell the lights to come on, but the board still doesn't boot because we're not getting any displays. So obviously it's not fully working. That wasn't the only issue. So I'll have to pull that board out and take a look at it again. Well, I took a look at this board again and I saw something that I didn't see the first time. Right down here, there was a little bodge wire between these two pads on this capacitor and resistor here. And looking at pictures and looking at the schematic, there was not supposed to be a bridge right there. And I figured out that this pin right here that's labeled A is a ground pin. So this end of the capacitor is connected to ground. But this resistor, the top pin right here, that's connected right to 5 volts. And so the effect that a little bodge wire between these 2 points would be is this resistor was essentially acting as a pull-down resistor from 5 volts to ground. And so the effect that would have on the entire board is it would pull down the entire 5 volt rail to ground. And so that would make basically everything not work right, and it would lock everything on because that is how the solenoids work. They get shorted to ground, and that's what makes them energize. And so every chip on this thing was not getting the proper 5 volts. It was getting ground because these 2 points were tied together when they weren't supposed to. So I'm going to put this back in again, and we'll see if it actually starts up now. All right, so with the original CPU board connected up again, what I'm going to do this time is, because I replaced the solenoid fuse, is if I hear coils lock on again, I'm going to turn it right back off. So if I hear that, that's what I'm going to do. Okay, not this time. The lights aren't on. Let's see if it boots. Well, it doesn't boot, but it didn't lock the solenoids on. Well, maybe it just needs that 3K resistor to go across those 2 pins on the test connector. So I put that back on. Let's see if it boots now. It does not. So obviously we still have a hardware-related problem on this board, because while we don't have the problem where the lights and the solenoids aren't on anymore, it still doesn't boot. So something is still wrong. Well, that's something we'll come back to later, because I do want to repair that original CPU board. For now, I just went ahead and put the NeWumph board back in, and it brought the system completely back to life. So we know that the problem is on the original CPU board, and it has nothing to do with the power supply or the driver board or anything else back here. What I want to do now is repair that one broken connection on this driver board connector and get the knocker working again. And you can see I've taken out that wire and just kind of left it hanging here, stripped back. But I can't just put a new crimp terminal on it and stick it in this connector, because Gottlieb changed these connectors when they went to System 80, and I'll show you what they used to look like. Over here I have a Gottlieb Close Encounters of the Third Kind, which is a System 1, and this is Gottlieb's very first solid-state system. I have a NeWumph board in this one too, but you can see what the connectors look like. They're a little different. The wires go through the back instead of the side. You can see they just stick right into their spots on the connector, and if I take it out, you can see it's the same type of connector. It's just an edge connector, and we have the pins in there exactly like a System 80. But on System 80 machines, they look like this. They have the same edge connector on the inside. You can see the pins exactly the same. But on the back, the wires go through the side of the connector, and it looks like that. And the crimp terminals are a little different. And from what I read online, these type of connectors came with the crimp terminals in them from the factory. And in order to put the wires through, you had to use a specific tool to insert them into those crimp terminals. And I'm not able to find crimp terminals that look like that. So what I need to do, instead of just repairing one wire, I need to repin this whole connector, because I tried putting a System 1 type crimp terminal in, and you see how on these connectors they have kind of a little section in the back? Well, that section holds on to the plastic connector housing, and it kind of locks it in there. And the System 1 crimp terminals don't have that, and so it just kind of shakes around in there and doesn't lock. So obviously that's not going to work. So what we have to do is replace this whole thing, and I found someone that made System 1 style connectors that'll work in a System 80, and so this is the new one I'm going to use. So the wires will go through the back like on a System 1, and then the pins will be visible there. And so I can use the same crimp terminals that I'd use in System 1, and it should work absolutely fine. But you see I have another connector that I 3D printed. Well, that's because I was taking the connectors off the CPU board, and I saw this wire just kind of hanging back here in a little screw terminal. And I wondered why they needed to do that, because both sides of this wire come from this little harness right here, and this just goes from the display connectors to the backboard. There's a few connectors down here that also have screw terminals, but they go between the backbox and the playfield, so you would want those to have screw terminals so that you can undo them if you wanted to separate the backbox from the cabinet to transport it. But this one didn't make sense to have a crimp terminal, and so I was just kind of looking at that and looking where it went. And it goes right to connector A1J3, which is a display connector. And if I take it off the board, I'll just take the whole harness out so I can show you this. On the back here, we've had a little bit of a problem. So what happened here is the wire must have popped out of the crimp terminal, and someone just soldered it straight to the back of one of those crimp terminals, and they had to melt the plastic in order to do it. And I looked inside, and The pin itself looks good and all the pins look just fine, but this was kind of a shoddy repair. It does work, but if you know me, I don't like shoddy repairs when I don't have to do them. So I'm going to replace this connector as well. I'm just going to repin it. And so this is the new one for that. Another System 1 style connector. So I'll fix that, and I'll fix the one for the knocker here. And I'm just going to do away with the screw terminal because you can see it just goes right from the connector through the screw terminal and right back into the same harness. It doesn't need to have a screw terminal. And someone soldered a little wire to extend it. They soldered it right there and have it coming into the screw terminal. So I'm just going to delete this wire and solder this original wire back to the other end, and I'll wrap it up with the harness so that it's nice looking. So I'll fix all that so that'll look better. And then over here, I noticed that this little ground wire has also had a repair done. And so what I need to do is desolder this and put some heat shrink over it so that this isn't exposed. So I'll fix that as well. And so I'm going to get all those things done, and I'll show you what it looks like when I'm finished. And I'll show you how this repinning process works in case you haven't seen it before, or you just want to relive the pain that you've experienced repinning them yourself. So I've done a couple wires already, and so this is the new connector here, and this is the old one. And what I went ahead and did, just so I knew which wire goes in which spot, is I put a little dot on pin 1 of each of the connectors, just so I know which end is pin 1. And so, because I don't care about this connector, I'm going to throw it in the trash when I'm done, I'm just going to use a wire cutter and snip the wire out right at the end of the connector here. So I snip that out, and that's pin number 2. And I'm going to need to strip a little bit of it back so that I have some wire to attach the new crimp to. And so that should be enough. And so what I like to do to make this process a little easier and go a bit faster is I want to put the wire somewhere where there's a surface. So I'm going to set it kind of flat like this. And these crimps, and this is what those crimps look like. You can see there's 2 sections on it. The outer one crimps the wire sheath, and the inner one crimps the actual metal wire. And since these crimps are pretty loose when they first come out of the bag, I like to put them just flat down like that and put it exactly where I want it. So right there is good. And then I take some pliers and I kind of pre-tighten the 2 sections that get crimped just so the crimp terminal doesn't fall off the wire. And so now it'll actually stay. It's not fully crimped yet. And you have to use a crimping tool. This is the tool here. You can see it's a pretty big thing. And so this is why you want both a flat surface and the crimp pre-tightened onto the wire, because now you have to take the wire in your crimp and put it in the tool in the exact spot that the tool crimps it at. And there's a little ratcheting mechanism in the tool. And once you get it in there, then you can just push really tight, and then the tool will loosen itself. And this might stick to the tool a little bit. And there is your crimp. So you can see it has crimped both onto the wire sheath and the wire itself. And so that is a new pin installed on that wire. But you want to make sure that before you put it in the connector, on the back side of the crimp, there's a little locking tab, and that is responsible for locking the actual pin in the connector. And so if you notice that it's been kind of pushed down a little bit from either your tool or you did it by accident, just take a little flathead screwdriver and kind of pry it up a little bit, just so that it sticks out a little. Then you can go ahead and put your terminal in here, and this connector I noticed has a very tight fit, which is good because then the crimp terminals aren't going to go anywhere. But on your connector, if you can't get it to go all the way in there, you can just take a little flathead screwdriver and push on the crimp terminal itself just to give you some more leverage, and then that should get it in there enough. And so then you can tug at the wire a little bit and make sure that it's locked in there, and it is. I can feel it. So that's not coming out. And that is one more wire redone and stuck in the new connector. And so that is the process of repinning connectors on a Gottlieb System 1 and System 80. So I'll come back once I finish repinning all of the wires. All right, I have finished the A3J5 connector. So that's what that looks like on the inside. All fresh new contacts, and this connector works perfectly. So I'm going to plug this in and we'll test the knocker and see if it works now. So on this game, the knocker is solenoid number 8, and in the solenoid test, it takes a little while for it to get to solenoid 8, so I'll start the test and we'll see if it fires. There it is. Go ahead and stop that. So there we go. That fixed the knocker. We had a bad coil and a broken connection on one of the connectors in the back box. So that is now working. All right, I have fixed all of the other wiring problems in this machine. I have repinned the A1J3 connector, so now there's not a big burn mark on the back. All the pins look good. And I was even able to transfer the original label onto the new connector, so that turned out really good. And as for that one wire that was connected with a screw terminal and had that huge wire dangling from it, I took out that additional wire and I cut the wire coming from the connector exactly to the size that I needed it, and I soldered the two together right there. You can see the heat shrink that is covering that. And so now it is wrapped very nice with the harness. I put another zip tie on there just to make sure that it was going to stay nice. And so that's how this looks now. And that's what it looks like when it's connected back up to the board. You can see we no longer have a dangling wire down by the driver board. We just have this part of the harness here going right up to those two connectors, and it looks very clean. I also went ahead and fixed that ground wire problem. I put some heat shrink over the exposed wire here, so that's not going to cause any issues if it happens to touch something metal. And I added an additional zip tie here just to clean up the harness a little bit. And I rerouted kind of the main harness coming up from the play field back into these two little plastic pieces that are designed to route the wires. So the back box looks a lot cleaner now, and every issue that I found back here has now been fixed. So the last thing I want to do in this video is rejuvenate the displays in this machine. And this process works for both System 1 and System 80 games that use these displays. So let me compare one of the good displays that's pretty bright to a dimmer one. The Player 1 display, you can see, is pretty bright. That looks mostly normal. But if we look at the Player 4 display, you can see it's definitely dimmer. And that just happens with these displays over time. They get dim, even to the point where they don't light up anymore. So the way to fix that is to rejuvenate them, and you don't even have to remove them from the game in order to do this. So let me show you how to do a Gottlieb display rejuvenation. So in my case, I am going to remove the displays when I do this because my displays are filthy still, and I need to magic erase the edge connectors with some contact cleaner to make them nice and reliable. So to rejuvenate one of these displays, the first thing you have to do is remove the cover if your display has a tinted cover over it. And so that'll give you better access to the main display itself. So what we're going to be doing is applying voltage to the filaments inside the display. The filaments are the thin little horizontal lines going across the entire display glass. There are, looks like 5 of them in one of these bigger displays. And if any of those filament strings are open, then your display will not work and it is garbage at that point. And since these displays are filled with a vacuum, there's no air inside of them. They have little getter points on the corners, and if those turn white, that means your display has gone to air, and that also means it will never work again. So because they're black right now, that tells you that the display glass itself is fine, that it's still holding a vacuum. So when you rejuvenate one of these displays, you have to keep something very important in mind. If you're doing it on a player display, you need to have a 12-volt source. But if you're doing the 4-digit credit display, you have to have a 6-volt source. And so what I'm going to be doing is using some clip leads that have 12 volts on them, and I'm going to connect them across the 2 outer pins of the display glass, not on the connector, but on the display glass itself. So one of those 2 is going to go on the leftmost pin here, and the other one is going to go on the rightmost pin there. And what you're going to see happen is the filaments glow bright red, and that's normal for this process. And so what we're going to do is maintain that connection for 10 seconds. So I'm going to connect it up, and we should see the filaments glow. There they go. They're actually not that bright. So that's about 4, 5, 6, 7, 8, 9, 10. And then let go. And that is how you do a display rejuvenation on a Gottlieb System 1 or System 80. It is that simple. And so now when you power up your display in your machine, it should be nice and bright again. But you may have to do it more than once if you have like a really dim display. But usually they wake up after just doing this process once. So I'm going to do all that to all of the displays. I'm going to clean them up, and then we'll see how they look once they've all been rejuvenated. All right, I rejuvenated and cleaned up all of the displays, and you can see they are much brighter, and they are all the same brightness. They look perfect. So just that simple little rejuvenation process will bring your displays back to full brightness like they were from the factory. And I also went ahead and cleaned the display windows on the back glass itself, and it looks so much more clear. So doing that and rejuvenating the displays made that look a whole lot nicer. And so I think that makes a good stopping point for part 2. We got a lot more of the backbox related issues fixed. There's still a couple minor things I want to take a look at before we start working on the playfield and cabinet side of things. So look forward to part 3 when we start doing some of that, and I will see you in the next video.